Okay, here is the second half of the story about the circles data. So as a reminder, the data curves. It curves up like a parabola, and if you look in your graphing handout, it suggests that if there's a parabola like this, if it curves up, y is proportional to the square of x, and so a trial plot could be to graph y versus x squared. So a different version of the input variable. The way to do that is to, in LoggerPro, is to insert a calculated column. So under data, new calculated column. The name of this will be, whatever my input variable is squared. So like width squared. We could call maybe D2 because it's diameter squared. This will be in square boxes, which I guess is a strange unit, but why not? And so to create this, we need to get a variable. So width is the variable we want, and we need to square it. So the square operator is caret 2, so raising it to the power 2. And so there's help for this. You can also insert mathematical functions if you want. So now if we click done, we have another column, width in square boxes. And so if we had 16 boxes, 16 squared is 256. So that makes sense. Now to visualize it, let's just get a new graph. So under insert, I did graph, and it comes up with, something. And so you need to choose the axes that make sense. I want output to be area, and I want input to be width squared, because I'm thinking about this handout. Graph y, area, versus x squared, and x is diameter. So there we go, width squared or diameter squared, area. Now, the idea is if the relationship is real, there will be a straight line proportionality between these two variables. That's what I see. To test it, if we insert a curve fit and do a simple proportionality with no intercept, you can try that out. We get 0.73. I don't feel bad about that. So let's see. If I push OK, so now my model, my equation or my mathematical model is that area equals 0.73 times width squared. So the area is 73% of the width squared. That's one way to interpret it. So I just need to modify something. Okay, now the interpretation. So area is equal to 0.73 width squared. I'm pretty sure about that relationship. So now let's talk about what we know about circles. The area of a circle is pi times the radius squared, and twice the radius is the diameter. So the area is equal to pi times the diameter over 2 squared, or pi over 4 d squared. Now together, this is about 0.78. So we could say that math tells us that area is 0.78 d squared. So how can we relate that to what we've already done? Well, the number of boxes is like the area. And experimentally, we found that 0.73 diameter squared described the area. Right? That's what this graph right here tells me, and that's what the graph behind it tells me. So 0.73 is experimental. 0.78 is theoretical. It's from a math textbook. The difference between those is going to be 0.05. And 0.05 divided by the number I think is real, 0.78, means I've got about a 6% error in my experimental measurement of pi, which I think is pretty cool. Now, a reminder, we weren't counting all of the boxes. We threw out this edge and this edge and this edge, and everyone had their own routine. So the fact that we're low also seems reasonable. All right, that's the end of the story that I've got for you.